Alright, here's a video doing a bandwidth example problem, and I'm doing the one at the top of the page here. And this one says, suppose a signal has a bandwidth of 1.5 megahertz, occupying a frequency range with low frequency of 750 kilohertz. What is the highest frequency of the signal? Well, you can think here that 1.5 megahertz, you can kind of do this in your head, 1.5 megahertz is 1500 kilohertz. And so if we're going from 750 as a low frequency, and then the bandwidth is 1500 kilohertz, then the high frequency is going to be 750 plus 1500, or 2250. So we can kind of guess, and so it's be 2.25, 2250, 2.25 megahertz. So let's draw a picture though first, and see what we've got here. I'm going to draw this picture like this. I'm going to give myself a little frequency axis, and I'm going to, let's see, I need up to about 3 gigahertz on this picture, so I'm just going to go 1, 2, 3 gigahertz. Okay, and 750 is 3/4 of the way up to 1, so you know what I'm going to do? I'm going to divide each of these in half, and then I'm just going to make the 0.25 and the 0.75 hash marks here on all these frequencies. Instead of trying to make 0.1, 0.2, 0.3, 0.4, 0.5 from 0 to 1, I'm just going to go 0.25, 0.5, 0.75, and 1. 1.25, 1.5, 1.75, and 2. And now I can draw a little picture of this bandwidth. It starts at 750 kilohertz, which is 0.75 megahertz. And so that starts here. This is F low. And it has to be 1.5 megahertz wide, which is going to be 6 of these 0.25 chunks. So 1.5 is 0.25 times 6, and so 6 chunks takes me up to 1, 2, 3, 4, 5, 6, up to 2.25. And I can draw this picture now. Here's what my wavelength range looks like. Okay? And so I can see the F high is 2.25 megahertz. Sorry, this whole graph is megahertz. Okay? Alternatively, I can go, look, the bandwidth is F high minus F low. And you should be able to do both, and you should be able to do either one, pictorially or with the equation. We want to solve this equation for F high. So F high is the bandwidth plus F low, which is 1.5 megahertz plus 0.75 megahertz. Notice that I turned the 750 kilohertz into 0.75 megahertz for the purpose of this equation. I cannot add a megahertz value to a kilohertz value. I got to add megahertz to megahertz for it to make sense. And this 1.5 plus 0.75 is our 2.25 megahertz. Okay? And so either way, drawing the picture or doing the equations, we get the same answer. So that's a nice check. Finally, what would the high frequency need to be changed to in order to double the bandwidth of the signal? Well, let's set the bandwidth to be twice 2 times the 1.5 megahertz. And that's going to be 3 megahertz. And therefore, F high is F low plus the bandwidth, which is 0.75 megahertz plus 3 megahertz, which is 3.75 megahertz. And what I'm going to do now is draw another picture that goes up a little bit further, say 1, 2, 3, 4 megahertz, F in megahertz. And again, I'm going to divide each megahertz up into 4 pieces. So these are the 0.25, 0.5, 0.75 values for each. And I'm going to draw my picture to show the spectrum here. And it's going to go from 0.75 megahertz up to 3.75. So 0.75 is here, and then 3.75 is here. So I just draw that in from 0.75 up to 3.75. And here we can say that the bandwidth, we can label it here, is 1.5 megahertz. And here we can label this bandwidth is 3 megahertz. Okay, from 0.75 to 3.75. Okay, so this is how you do this problem. And again, you should be aware of how to do it using either a diagram pictorially or using the equations. Okay, I hope this helps.